Hey everyone, and welcome to the Explainer. So grab those digital notebooks and pencils, because today we're building a really fundamental math toolkit. Think of this masterclass as your ultimate guide to mastering angles and their relationships. Whether you're constructing a literal skyscraper or just trying to ace your next geometry test, you need the right tools. And today we're going to build those tools together, step by step, right here on screen. Here's our lesson plan for today. We'll start with an introduction to angles, move through the 6 angle types, and then unpack the complementary and supplementary rules. From there, we'll level up by solving for unknown angles, learn how to use the angle bisector, and finish the whole thing off with a final practice challenge to test out your new skills. Okay, let's dive right into Section 1, Introduction to Angles. Every great builder needs a starting point, and in geometry, that starting point is the angle. Imagine we're sketching on a fresh sheet of notebook paper right now. Basically, an angle is just the union of two rays starting from a single common point, which we call the vertex. We measure the space between these rays in degrees. Now, the absolute most crucial rule to write down at the very top of your notes is this. A full, complete circle measures exactly 360 degrees. Every other angle is really just a slice of that 360-degree pie. Let's test that out immediately. I actually want you to pause the explainer right here and try this yourself. If you have a given angle that measures 130 degrees, what is the measure of its reflex angle? The angle that goes all the way around the outside to complete the circle. Take a second, use that 360-degree rule we just talked about, and give it a shot. All right, let's write this out step by step together. Watch as I set up the equation here. We know the total circle is 360 degrees. So our inside angle of 130 degrees plus our unknown reflex angle must equal 360. To find the missing piece, we just subtract our known angle from the total. 360 minus 130 gives us a reflex angle of 230 degrees. This is exactly why subtraction is your best friend when dealing with circles. Now that we know how to measure our angles, we've got to organize them. Let's move on to Section 2, the 6 angle types. Look at this brilliantly laid out machine of angular measure. It breaks down all 6 distinct types beautifully. Down at the very bottom, we start with a 0 angle at exactly 0 degrees. Then we open up to an acute angle, which is anything less than 90. At exactly 90 degrees, we hit a right angle. Go a little wider, and you're in obtuse territory. At exactly 180 degrees, you have a flat, straight angle. And anything beyond that, bending backward all the way up to 360, is our reflex angle. Time to actually put that classification to work. We need to find the value of x if a right angle has a measure of 3x plus 15 degrees. Now listen, this is a super common exam question. It tests if you remember the definition of a right angle and if you can apply a little bit of algebra to it. Let's work it out on the notepad here. First, we write down our fundamental fact. A right angle equals exactly 90 degrees. So we set up our equation. 3x plus 15 equals 90. Now, be careful here. When we move that positive 15 to the other side of the equal sign, we have to subtract it. So 3x equals 90 minus 15, which leaves us with 3x equals 75. Finally, we divide both sides by 3. And boom, we get x equals 25. Let's draw a massive box around that final answer. It's just incredibly satisfying when the algebra perfectly locks in with the geometry, right? Okay, let's switch gears to Section 3, Complementary and Supplementary Rules. These are the combination tools of our geometry toolkit. I highly recommend highlighting these definitions in your notes because they are literally the keys to unlocking complex geometry puzzles. Complementary angles are 2 angles whose measures add up to exactly 90 degrees. Supplementary angles are 2 angles whose measures add up to exactly 180 degrees. An easy way to remember? Think of C for corner, a 90-degree right angle, and S for straight, a 180-degree flat line. Let's see a quick trick to help lock these baselines into your memory. Let's find both the complementary and supplementary angles for a single angle measuring 35 degrees. Watch how I set these up side by side. For the complement, our baseline is 90. We subtract 35 to find the missing piece, giving us 55 degrees. For the supplement, our baseline is 180. We subtract that exact same 35 degrees, which gives us 145 degrees. By practicing them together like this, you cement the difference between 90 and 180 in your mind forever. Now we're ready for Section 4, Solving for Unknown Angles. This is where we take those basic rules and start using math to find hidden, adjacent angles.
Take a look at this diagram. We've got two adjacent angles, meaning they share a side, and their outer edges form a perfect perpendicular corner. See that little square symbol in the corner? That tells us everything we need to know. These angles are complementary. Together, they absolutely must sum to 90 degrees. Our two angles are 7x plus 2 and 3x minus 5.
Let's construct our equation. We add the two expressions together and set them equal to 90. So parentheses 7x plus 2 plus parentheses 3x minus 5 equals 90. First up, let's combine our like terms. 7x plus 3x gives us 10x. Now, many students make a mistake in this step right here. We have a positive 2 and a negative 5. Combining those gives us a negative 3. So we have 10x minus 3 equals 90. We add 3 to both sides, getting 10x equals 93, divide by 10, and we get x equals 9.3. Now, I want to pause here and emphasize something important. Please do not panic if you get a decimal. Decimals are totally normal in geometry and algebra. Your math is solid, I promise.
Let's add the final tool to our belt in Section 5, the angle bisector. Think of this one as the precision cutter of your math toolkit. The word bisect literally means to cut into two equal parts. A bisector is a ray that slices an angle exactly in half, creating two perfectly congruent pieces. In this problem, we're told we have a straight line at the bottom. We have an angle of 40 degrees, an angle of 90 degrees, and a much larger angle, ABE. And crucially, we're told that ray BD bisects that larger angle ABE. We need to find the measure of just one half of it, angle ABD.
Let's unveil the logic step by step. First, we use our supplementary rule. We know a straight line is 180 degrees. If we subtract the 40 and 90 degree chunks we already know, we find that the total measure of the remaining angle ABE is 50 degrees. Now we bring in our bisector tool. It slices that 50-degree angle right down the middle. We divide 50 by 2, leaving us with exactly 25 degrees for angle ABD. All right, you've acquired all the tools. It's time for Section 6, Final Practice Challenge. Let's see if you can put it all together in a little boss battle to finish out this explainer. Look closely at this straight line, ZXY. We have two adjacent angles resting on it. One is exactly 110 degrees, and the other is an algebraic expression, 2x plus 10. I want you to pause right now, use your straight line rule to build the equation and solve for x. So did you get it? Because they sit on a straight line, they're supplementary. So 110 plus 2x plus 10 equals 180. Combine your numbers to get 120, subtract that from 180 to get 60, and divide by 2, x equals 30. Go ahead and box that answer because you have officially mastered the basic 2D angles toolkit. But here's a provocative thought to leave you with. The screen in front of you is flat, but the world is not. How do these exact same algebraic tools, these complementary and supplementary relationships, govern the complex 3D architecture of the bridges we cross and the buildings we live in every single day? Keep those digital notebooks handy because this math is literally the blueprint to reality. Thanks for joining me on The Explainer.